So welcome to my talk. I'm going to talk about some infra topics, but first I'm going to talk about me a little bit so that you get to know me a little better. So I've been neck deep in IT for about 13 years, including my university studies. And I'm not a wunderkind. I didn't start coding at 7 and stuff like that. There are a bunch of guys still who are like that, but those are a dying breed of IT people. So I'm about 8 years doing this professionally. So I've been making money for 8 years with my knowledge. From that 8 years, it's about more or less 7 years Java. 5 years Linux stuff, so I'd say that I'm pretty good at that, and yeah, a bunch of other technologies I've also worked with over the years. So like in least recent. And currently I work at CloudStorm. It's a robotic process automation company, and I'm doing site reliability engineering there. That's sort of like DevOps. So I'm kind of a DevOps evangelist at the company. Clearly I'm not an authority on NodeJS. I'm a newbie. But NodeJS is not that hard to pick up. Don't kid yourselves. It's another language. Nothing new, no big new concepts in there. But actually, it's a really awesome iteration on earlier concepts, and I really like it. So now this is a JavaScript meetup, but my talk will limit itself to Node. Some parts of the talk will also be relevant to front-end guys, but when talking about infrastructure, we usually talk about things that we host on the server side, not things that run in a client. So, infra-friendly Node.js, what does it mean? So, it sort of means that we, as developers who are developing services in Node.js, should kind of know some parts about how it's going to run. And it has a bunch of aspects to it. So one thing is, and here I'm going to kind of summarize the entire talk in 5 minutes. So if you want to leave after 5 minutes, you can leave. But please don't. So keep things secure. That's really important with any kind of code. That means update your dependencies. Keep in mind that there are security vulnerabilities every day introduced, discovered, etc. And you need to keep your dependencies up to date. So update the deps. And the third point is lint and test. That's also part of the security aspect of bugs. So the first ones, those are other people's mistakes. The third one is your mistakes. So both are quite important to avoid. The next one, respect the proxy. This means you don't need to handle CORS in your application. That's going to be handled by a reverse proxy much better than you can. You don't need to handle authentication, or it's not just you who has to handle authentication. Firewall rules, firewalling, like web application, firewall stuff. You can do that, but it doesn't really matter because there will be a proxy in front of your service that also does that. So it's like things like Helmet.js, a pretty cool project, but if you are running a microservice stack, you probably already have a web application firewall that does the same thing. So next, respect the OS. So their process. If the OS asks you about your health, you tell them. The OS hates it if it cannot tell if somebody is healthy or not. And if the OS asks you to die, you die. You fucking die. Either you kill yourself, or the OS is going to do it for you. So, but it's still better to commit harakiri than wait for somebody else to do it. And I'm going to explain why. Third, dumb logging. Don't overthink logging. Don't use log files. Don't use log rotation. You don't need to take care about fancy timestamps because the logging infrastructure is going to handle that for you. You just log to standard streams like standard out, standard error. Oops, yeah. So you might say, oh my God, those are important. Yes, those are important, and those are not your concern. Those will be the concern of a log rotation, log collection tool. So that's about what we are going to talk about, or I am going to talk about. You're silent. I hope so. So let's go a little bit deeper. So infrastructure-friendly Node.js is secure. So it's super secure. It needs to be. This means you will not run well-known security issues in production. So NPM Audit. You need to keep your eyes out for security flaws, prevent known security issues entering your code base. This means you need to run NPM Audit on pull requests. And also you need to run that on your CI if you have a regular CI build next to pull requests. That's kind of a good practice, not just to build pull requests, but also your master branch. But running these audit scans only on changes is not enough. Why? Because you might not touch that service for like half a year. And in that half a year, a bunch of new security issues are discovered, made public, and boom, your service is already vulnerable to well-known issues. And that means you need to run these scans also periodically. And this is the key, because a bunch of people misunderstand and think, oh, I just run my security scans in a CI on each change and I'm good, I'm covered. But basically, time shows that code first changes rapidly and then doesn't change for a bunch of time. And that doesn't change for a bunch of time is a huge security risk. Yeah. So you need to be alerted when your live system is susceptible to security issues. Next, this is not really a security topic, but also a good practice. Use npm CI instead of npm install. It uses the package log JSON, which is great because package log has all the URLs you need to download for your project when you check it out. And also, it's reproducible like this, because you can delete anything from npm, so it's not really reproducible, but still, if you know the exact version of every single dependency and how do you say this? Transitive, yeah. I drew a blank there. So the package JSON, the package log JSON records all your dependencies and transitive dependencies at the exact same version you had them when you ran npm install. And that's why npm CI is important. You get the exact same dependencies everywhere. That's why it's CI, because yeah, you want the exact same dependencies in the CI every time. And then the third, yeah, it's much faster. Really, try it out. If you haven't tried npm CI for development, that's awesome. You usually don't bump your dependencies every 2 hours, but you will check out projects and then bootstrap your node modules, and it's a really fast way to do that. Next one, npm outdated. This is a great command for NPM. It shows all your outdated dependencies, shows you which dependencies can be updated automatically with NPM update. So you can keep your dependency up to date with it with NPM, the update command. And then it also says which dependencies have breaking changes that you need to manually inspect and manually upgrade. But usually it's just NPM update, I'm good. Next one, static analysis tools. I love those. ESLint is a static analysis tool. Who uses ESLint? About 1/3 of the crowd. Yeah, 1/3 of the crowd. Everyone should use it. It's very low effort to introduce into your project. It's the single most important thing in a Node or any JavaScript project for that matter, even front-end, because static analysis will catch real bugs without writing a single line of tests. So it's much better than tests in that regard. You don't need to maintain any test code. You just need to maintain your rule files if you have custom rule files, but other people will do that for you. There is a big community around that. Yeah, so it's the single best thing you can do for your project regarding code quality if you don't have that yet. So it catches bugs, and it catches soon-to-be bugs. Because, yeah, not everything that's catched with ESLint rules is inherently a bug, but it's shitty code. And shitty code will turn into bugs. So next really important part, TypeScript. I love TypeScript. It's the best thing since sliced bread. Static types in such an elegant manner. You can look at TypeScript code. It's like duck typing. It's beautiful. And it's statically typed. Statically typed languages catch bugs, obviously. That's why we love them. It helps managing complexity, and that also catches bugs. And it helps you write more robust code in general. So if you don't use TypeScript, please consider it. It's not really obligatory, but I'd say it's probably one of the best choices your team can make nowadays if you're still writing plain JavaScript. Okay, so that's about the security and code quality parts. Yeah, and here I don't have a slide for that, but since the previous presenter mentioned tests, writing tests is also important. It's very difficult, but yeah, I can give you more about that. You have to learn it. So next topic, it's life and death of Linux processes. So playing nice with the OS usually means something about the life and death of a process. Processes are born, then processes either die on their own because they are buggy shit, or they will be asked by the OS to die, or killed by the OS if they don't die. And how does it happen? It happens with signals. So this guy is the OS, and he says, die. And then you have to, you better die, or he will get you killed. So the OS asks sins from the process with so-called signals. So like these are the usual signals in Linux. etc is not a signal. It's just that there's a bunch of other signals that are less commonly used, and I was lazy to write them all out. But basically, signals are a kind of inter-process communication. So it's not necessarily about life and death. There are user signals also, like you can send a signal to a process that triggers a configuration reload, or that turns on or off some functionality, but those are less commonly used. The config reload part is still sort of commonly used, but the most common use case is like these four. Yeah, and the important thing is these three, so sigint, sighop, sigterm. So sigint, interrupt, sighop, hang up. This is like from the phone era. And sigterm means terminate, but they are nowadays kind of used interchangeably. They all mean, please stop what you're doing. And these can be intercepted, and sick kill cannot be intercepted. So if you get a sick kill, you will be killed. The other three is please kill yourself. So that means there are signals that can be handled. Processes can handle or can define signal handlers. And these are callbacks. JavaScript developers are been doing that for years or decades now. So they are regular callbacks. You get a signal, the callback is invoked and executed. So these can be handled. This cannot be handled. So what exactly should a signal handler do? Well, it should close existing connections or finish serving them. And then it should also set the service in a state where it doesn't accept any more incoming connections. So it's like the OS says, please shut down, and I have 5 requests processing. That means first thing I do, okay, I say stop, I won't accept any more incoming requests, and then I try to finish those 5 or 6 requests. If I won't finish that in a set of time, then I will get killed. If I finish those in a set of time, I exit and then I die. Yeah. So there are some NodeJS libraries that help you with that. So there's this terminus library, exit hook, and death. Really great name. I suggest using terminus. It's a quite popular library, and you will see why I'm suggesting it, because it also has some other features. And those other features are related to service health. So previously I was talking about the OS communicating with the service that it should die. And service health is the service reporting on its own health to some monitoring tool. Maybe the OS, maybe not, maybe some service. But the thing is, it reports its health. It means, oh, something happened, I cannot access the database anymore, please don't send me any more requests until I recover from this misery. And yeah, so that's the primary goal. Yeah, so why do we need this? So for example, load balancing. Who knows what load balancing is? Okay, a bunch of guys, great. I'm really happy about that. I thought there were going to be less people knowing about it. So load balancers need to be told which backends are healthy and can receive requests. How we determine which backends are healthy are periodically polling the health endpoint, for example. So right now, a good practice is we have a /health endpoint that returns 200 if the service can accept requests, and 500 whatever if it can't. Yeah, another use case is like signaling the orchestrator, like Kubernetes. Who knows Kubernetes? Some guys, great. Really huge tire fire project. I love it. So what health checks communicate to the orchestrator is like sort of the same as with load balancing. You can send me requests, but it's not the load balancer who configures this on its own, but like the orchestrator is collecting endpoints, then telling the load balancer these are your endpoints. Or the other one is, and there's another use case with orchestrators is if a service cannot recover from its unhealthy state, then the orchestrator will know, okay, this hasn't been healthy for like 30 seconds. Now it's been off from the load balancer for 30 seconds, but it's not recovering. I'm going to kill it. So it's also possible to like signal an orchestrator to please kill this process and spawn another instance. So how do we implement the service checks? So I already explained this, it seems. I rushed a little bit. So like there's readiness and liveness checks, what I just explained. So like readiness is that I'm ready to receive requests, and then it can also signal, right now I'm back to not being able to, and then I'm again able to. And liveness is the please kill me now check. Usually these are served by the same endpoint because it doesn't really matter, or doesn't really make sense to implement two separate endpoints for most services. But the point is that it's possible to distinguish between the two, even though most of the time it's the same endpoint. So these are the node libraries that help you with these endpoints, or implementing these endpoints. Like again, Terminus, that's why I suggested that, because it's designed for like the Kubernetes use case, but if you need any kind of health check, it's great. Then it's these cloud native projects which I don't know, I just found them. It's like Health Connect, seem pretty reasonable. So I recommend Terminus again. Okay, third topic is logs. So I've been talking shit about logs previously for a reason. And that's because modern platforms have, all modern platforms have log collection built in. Those who don't have that cannot call themselves modern. And so these platforms take a lot of burden from your shoulders. That means you can hand a bunch of concerns to the platform and don't care about it anymore. So such a platform is, one is this EFK, it's called EFK, it's Elasticsearch Fluent Bit Kibana. So it's like the Fluent Bit part is pushing your logs into Elasticsearch. So it's the log collector, and Elasticsearch is visualized by Kibana. So you can search on a nice web GUI your logs. Another one, more lightweight, is this Grafana Loki, and then this Promptail thingy. So here the Promptail is pushing it directly into the Loki service, and then Loki is storage and visualization combined. And then, yeah, just so that I'm putting here a cloud provider specific solution, so like Amazon and also Azure and Google and DigitalOcean, etc., have some sort of log collection, some more mature than the other. CloudWatch is really mature, so if you're already running your stack in Amazon, then CloudWatch is a safe bet in this regard. And then, surprise, surprise, systemd and journalD combo, the regular basic bare bones Linux box, also have a log collector called systemd, and then the storage called journalD. So it's journalD is the daemon that's serving that. So even on a bare bones Linux setup, you don't need to mess around with log files. Set up your systemd service, log to standard streams. Everything will be in the journal, time-stamped, everything pretty, etc. So that means log files are a thing of the past. Modern platforms collect straight from standard streams. But you might say, but Zoli, I am not using Kubernetes, I'm not using Amazon, what do I do? And that's what I said, forget about it. If you're still on a regular Linux box, just use systemd, use standard streams, and yeah, the other two, log to the standard streams. Timestamps, this is a more controversial one, I must say. Not everyone agrees with me in this, but it's a pretty opinionated thing. I say if you log, don't log timestamps, because the log collector will apply timestamps to your log lines. And this is because there's this pesky time zone representation issue. If I'm going to log timestamps, who knows that the guy in India reading the logs and trying to debug a service will know when that event happened if it's in Central European time. Log collectors can render the timestamps in their locale, in their time zone. And if you take over that responsibility from the log collector, your service just gained a huge mess of having to deal with time zones. That's a huge problem, and it's a huge issue. There's a really nice page explaining about it. I'm going to put that in the meetup page. You don't want to mess around with time zones. It's a pain in the ass. Yeah. So leave it to the collector. So log rotation, don't beat yourself about that. Just forget about it, not your problem. Enjoy life. It's the platform that's going to solve that. Okay, next topic, HTTP proxies. Who heard of proxies? Yeah, I saw that. Who's using JavaScript proxies? Not many people, but in concept it's the same. The only thing is that JavaScript proxies are in process, wrapping an object. HTTP proxies are out of process, also most of the time in a different machine, but they are still conceptually wrapping your services. So from JavaScript functions and other functions wrapping those functions, we move up to the infrastructure level where we have other kind of functions called services, and then other kind of wrapping decorators called proxies. So like decorator pattern on the infrastructure level. So two kinds of proxies, forward and opa. Sorry, I mess up my slides. God damn it. I usually do that. So yeah. So we have forward proxies and reverse proxies. So you can see it's forward or reverse by where the internet is on the diagram. It's a great Cloudflare documentation. So the point is, with forward proxy, the proxy sits right at the users, and then every traffic goes through the proxy before it goes to the internet. With reverse proxy, that's why it's reverse, because after the traffic comes from the internet, it's touching the proxy and then going to the machines. So yeah, this is the documentation page. So this is like just to get on the same level. We're talking about reverse proxies, not forward proxies. But actually, both are useful. So why are we talking about proxies? Proxies can be used for security features. You don't need to implement that in each and every one of your microservices, because maintaining all the same set of security features in every single microservice, it's a pain in the ass. But luckily, you can say, I'm putting a reverse proxy in front of all of my microservices. I'm handling these concerns with a single configuration. So concerns like TLS, concerns like authentication, traffic logging, CORS, really hot topic nowadays. Like who heard the Zing stuff with macOS just a few days ago? Pretty embarrassing stuff. Application firewalls, policy enforcement. So these are like big words. Big words, we don't know what they mean, but security people love them. So these are like features. All of these are features that if you have a single node service, it's okay to put it in your node app. But if you're having like starting with like, I don't know, 5 or 10 services, microservices, you don't want these in your node apps anymore. Put it into the higher abstraction, into the proxies, into the decorators. Another thing that proxies are good for, building robustness into your solution. So like load balancing, that's the number one, everybody knows, feature. Makes your services robust. If one of your instances dies, it just goes to the other instance. Nobody notices. The other one is caching content, static content. Compression, like gzip, stuff like that. You don't need to do that in Node. You can do that in a proxy. Request retries. This is a really interesting thing. Let's say one of your services just dies in request. Somebody queries your site, and while the backend is serving your request, it dies. Without request retries, your customer will experience service degradation. With retries, the proxy will intercept the failure, see that the request didn't finish and there was some issue, and then instantiates a new request to a new instance. The new instance serves the request, goes back to the client. The client never notices that the instance just died in request. Short-circuiting. This is again something about service death. If a service is more or less permanently dead, meaning within half an hour, short-circuiting helps recover faster. Meaning a request comes, it won't wait for the timeout period like 120 seconds or whatever, but it will know, okay, the first request for that other request died, so I'm going to put this backend into a short-circuit mode, and for the next, I don't know, half a minute, I'm going to just never send it to the backend. I'm assuming that the backend is dead. That's the short-circuiting part, so it's fail fast. The proxy identifies the service is dead, and then it fails fast. It says, okay, I'm going to give it a minute, and then I'm going to try again. And canary deployments, also blue-green deployments, also A/B tests. These are kind of the same generic area, meaning who heard about canaries? Some guys. A/B tests, great. What was the second one? I don't know. Blue-green deployments, nobody, great. So canary deployment is like I'm rolling out a new version of the service, like v1.2, and I have 1.1 versions out there. And I don't want everyone to go to the 1.2 instantly. I just say that 10% of the traffic is going to the new service. Or even better, I'm going to say the customers who don't spend more than $10 a month on my site will go to the new version. So like the really paying customers, they go to the old proven version, spend their good money there, and the guys that don't spend, they won't notice a service outage. So there's canary deployments. And this is like big business. So a lot of money. Okay, so that's about proxies. So reflecting back on Node.js, now that we've learned about like proxy capabilities, always think about your infrastructure. Is what you're doing an orthogonal concern? So that orthogonal means cross-cutting, something like that resembles a decorator. Does it look like the same for every service? So would I need to like duplicate code everywhere that looks basically the same? Is it, I don't know, an express middleware? That's a really common use case that can be put into a proxy. So no need to accumulate additional dependencies in the service. Just move what you can out into proxies and be happy. Yeah. So that's about it. So this was my talk. Thank you very much. Yeah, I appreciate every one of you coming. It was really great. Thank you for listening.